let's start our today's class. So this is lecture 13 on computer networks, and we have discussed about classless addressing. So we were discussing classless addressing, and we have solved simple questions like an IP address in a block is given to us, and we were trying to find what is the first address, what is the last address, and so on. Okay, so just for the sake of practice, let us do one or two more questions regarding that topic. Okay, and then we will shift to the other topics also. Okay, so let us suppose we have an IP address given as 150.40.30.57. Okay, /27. So the moment you see this slash, that is CIDR notation, you will say okay, it is classless addressing, it is not classful. So do not say by seeing this it is class B. No, do not say like this, it is not like that. Okay, the moment you see this, it is classless. If this CIDR notation is not given to you, that means if only this IP address is given, let me copy it out. Okay, if only this is given, okay, then you will say uh, then you will say okay, it is of class B. Okay, if nothing is given like CIDR, it is class B. If something is given, then it is classless. So /27 means 27 ones in net mask. 27 ones in net mask. Okay, so that means you can roughly think that net ID is of 27 bits. So directly indirectly, this means, say this, net ID and host ID. So net ID is of 27 bits, so host ID will be of 32 minus 27, it comes out to be 5. Okay, so total this is 32, so 5 bit is host ID. Okay, yeah, so now they will ask the simple questions like what is the first address, what is the last address, net mask, and so on, everything they will ask. So let me jump to the next slide and tell you the questions which can be asked. Take the snapshot. Done. Yes, please let me know. Okay, so yeah, so I hope you have taken it. So yes, so what we will say, yes, if you have any doubt, then you can ask me from here. Yeah, I am audible. Let me check. Yes, please let me know I am audible or not.
Yes, sir.
Okay, so you have any doubt here?
No, sir.
Okay, yeah, so you have taken the snapshot.
Yes, sir.
Okay, yes, so now we will say so questions which can be asked is, say they will say what is the net mask. Okay, and they will say what is the first address, they will say about last address, then total addresses in the block. Okay, and then total host in the block, total hosts. So net mask, that is 27 ones. 27 ones is very easy. So 255, 8 ones consumed, 255, another 8, 255, another 8. To 24 ones are consumed. Now 3 ones we have to keep. So 3 1 means 128, 64, 32. So it comes out to be 224. Okay, so dot 224. Okay, then what is the first address? First address is very simple. What was that? 150, 40, 30, 57. 150, 40, 30, and 57. So first address will be you will AND the net mask, okay, with this IP address. So if we AND it with this IP address, what we will get? Okay, so I think their sizes are different. So 255.255.255.224. So it comes out to be 150, 40, 40, 30 and 2 to 4, first three are ones, but in 57 see this 128 0, 68 0, 32 will be 1, so answer will be 32. Okay, so I hope you have got the point. So first address will be 150.40.30.32. Okay, what about my last address? Last address will be, we will knot the net mask, same procedure which we have done in the previous lecture. Okay, I'm doing the same thing only. So last address, how we will find? You just take knot of the net mask and OR it with the given IP address. So given IP address is 150.40.30.57, not the net mask 0.0.0. First three are 1, so last 5 are 0, so last 5 ones it will become 31. Okay, yes, so finally what we will get 150.40.30.31. Okay, sorry, it is not 31. What we will get is 57 and 31 we have to do OR operation now. Okay, so what we will get, so 32, then for 57 we will put some values here. Okay, and what is here 31, so 31 means 5 ones, 1 2 3 4 5, and here this sixth bit will also be 1, so total 6 1 is 63. So this is our last address. Last address is 150.40.30.63. please let me know if you have any doubt here. Okay, it's simple logic. So 57, I have just taken that 32 bit is 1, rest other bits 0 or 1, it hardly matters because we are doing OR operation. So whatever maybe was there, it hardly matters to me. I will simply get these 5 ones, and because of this I will get one more one. So 6 ones total, that is 63. So 150.40.30.63 last address. Total address is very simple. I have told you in the previous slide only 5 bits, so 2 power 5, that is 32. Total host 2 power 5 minus 2, that is 30. This is my answer for this question. So you can take the snapshot. Once done, please let me know, then I will jump to the next slide.
Done, sir.
Okay, so like this they can ask any question. For example, they can give say 10 20 30 40 slash, let us suppose we take 23. Okay, so the moment CIDR, you will say no, it is not class full, it is classless. So do not say by 10 it is class A. No, it is classless addressing because CIDR notation is given. Okay, so here also we will try to find the net mask. Okay, net mask, first address, last address, okay, total addresses and total host. Okay, so very simple question. Net mask is very easy. 23, so 23 ones, try to do 23 ones. So 255.255, and if I put 255 here, it will be 24 ones, but I need 23 ones, so subtract 1 from here, but you will get 254.0. What is the first address? First address is very simple. You just AND this net mask with this IP address, you will get the first address. So let me copy it out. This and this. So you just AND it. So finally what we will get? After ending 10.20.c, here in 254 last bit is 0, in 30 also last bit is 0. So rest every bit as it is, so what we will get 30 as it is. Okay, dot 0. So 10 20 30 0, that is very easy. First address is this. I think nobody is having any doubt here. So next is last address. So try to do it. If you have any doubt, you just try to do it. Okay, so see this 254 means 1 2 3 4 5 6 7 and last is 0. 30, forget about everything. 30 is this bit 0, and whatever may be here, that thing will be copy pasted here because we are doing AND. So everything will be copy pasted. So what we will get 0 0. So here also everything from here what we have done here, it will be same to same as it is. So directly indirectly everything is same here with what we have got it. So this is nothing but your 30 only. That's why I have written here 30. Okay, so 10 20 30 0. Last address again very easy. So you just knot this and OR it with the given IP address. So I will take this and or with this. Okay, so what I will get 10.20.series 1 and here 30. So obviously what we will get 31. Try to imagine yourself. You will get the answer, and here 255. So 10.20.31.255. Total address is very easy. So 23 bits net id. So last 9 bits are host id. So total addresses will be 2 power 9, that is 512. Total host 2 power 9 minus 2, that is 510. This is my answer. So you can take snapshot of this. Everything is on one slide. Then I will jump to the next slide. If you have any doubt, you can ask me. Yes, done. Okay, so I hope you have taken the snapshot. I'm jumping to the next slide now. Yeah.
I would like to have a snapshot of first slide also, sir.
Okay. From here.
Yeah, sir.
Hmm.
Done, sir. Done,
This.
sir. Yes, sir.
This also done. Okay.
The previous one, sir. Previous one. Sir.
Okay. This one.
Sir. Done, sir.
Okay. This one.
Done, sir.
Okay. So that's it. So we have done first and last address type of questions. These were very important as related to gate. Many questions have been asked. So they will directly give you any IP address and they will say what is the net mask, what is the first address, last address, total host, and so on. These 5 questions are very common, very important. Okay, so I hope you have got the point. So let me jump to the next slide now. Okay, so now we will see how blocks are allocated. Okay, so the major issue in classless addressing, classless is block allocation. Okay, so major issue in classless is block allocation. That means how these blocks are allocated. Okay, so these blocks are given by ICANN, Internet Corporation for Assigned Names and Numbers. ICANN is Internet Corporation for Assigned Names and Numbers. ICANN. Okay, this ICANN organization will give blocks to ISPs, that is Internet Service Provider. This ISP will give IP addresses to home users. Like this, this is the hierarchy. Okay, so major issue in classless is block allocation. So block allocation is done by ICANN, and these blocks will be allocated to ISPs, and this ISP will give IP addresses to home. Okay, yes. So this ICANN is giving IP addresses to ISPs or very big organizations like NASA or other Google and so on. Very big organization need lot of IP addresses, so they will demand from ICANN, and home users will take IP addresses from ISP. This is the basic hierarchy, that how IP addresses are given. Okay, so we have some restrictions. These questions have been asked in GATE, so I'm changing the color here. Restrictions for block allocation, very important. Directly they have been asked in GATE. Restriction in block allocation. So the very first is number of IP addresses demanded should be power of 2. Number of IP addresses demanded should be power of 2. So that is, if some organization need 1000 IP addresses or some ISP need 1000, what you will give? 1024. Okay, if somebody wants 200, you will give 256. If somebody wants 500, you will give 512, and so on. Okay, so number of IP addresses demanded should be power of 2. That is the first restriction. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so next restriction is if n is the number of IP addresses demanded, if n is number of IP addresses demanded, then first address must be divisible by n. Must be divisible by n. Same restriction whatever we have done in supernetting. Okay, same restrictions we are copy pasting, and as it is they have been asked in gate. So if n is the number of IP addresses demanded, then first address must be divisible by n. And what reason I have given you? Routing possible. So that routing become possible. Okay, routing become possible. Otherwise routing will not be possible if first address is not divisible by total number of IP addresses demanded. Okay, so this is important point. And the last third point is block must contain addresses in contiguous fashion. That is also similar to supernetting only. Okay, block must have addresses in contiguous fashion. Okay, block must have addresses in contiguous fashion. This is the third restriction. Okay, so total three restrictions are there, and all these are just like your supernetting only, and they are very important and have been asked in gate many times. So simple. The very first is power of 2. Okay, second is first address divisible, third contiguous. That's it. So three very easy restrictions are these. Okay, yes. So let me jump to the next slide. Take the snapshot.
Done, sir.
Okay, so these three restrictions were same as supernetting. Okay, so questions are also very similar. So for example, they will say question is which of the following IP addresses can be starting address for 1024 addresses. Okay, so for 1024 addresses, starting address we have to find. Options are given. Starting address, which of the following can be starting address? That is the question. A option is 10 20 30 0/22. B option 10 30 50 60/22. C option 10 30 40 0/22. Okay, and then we have D option as 10 30 35 0/22. Which is correct, which is wrong? So 1024 IP address is starting address we have to find see. So here starting address is last 8 bits are 0, and here 1024 means last 10 zeros we want, last 10 zeros. So 8 zeros are okay. Here 2 zeros we want. 20 means divisible by 4. 30 is divisible by 4? No. So just cut it. Next, here 60, simply cut it. No need to check. Why? Because starting address here should all zeros. You need last 10 zeros. Last 10 zeros. So here in 60 we are not having last 10 zeros and all. Just cut it. This 8 are 8, okay, and here 40. Last 2 are zeros, na, because 40 is divisible by 4. So yes, it is correct. Okay, and what about this scenario? No, I will cut it. Why? Just because here 0, it's okay. 8 bits are continuous zeros, and here 2 zeros we want, but here we do not have 2 zeros in the end. 35 is an odd number, na? So just cut it. Any doubt here?
So on what basis that we decide now?
1024 addresses were there, na?
1,000 and above. So 10
Huh?
zeros.
Yeah, last 10 zeros. So you just check here last 10 zeros in this IP address.
That's what, sir. Like, why did we cross that? Because 40 we opted.
See, last octet is zeros. So 1, 2, 3, 4, 5, 6, 7, 8. 30. What is the binary of 30? 1, 2, 3, 4, and this 0. This is 30. So do we have last 10 zeros?
All right, sir. Understood now.
Okay, yeah. So shortcut, if you want, then we can make formulas also, but I'm not telling you just because you might not be able to remember all these till gate exam. It's better to do by common sense. So shortcut is, this is third octet now. First octet, second octet, third octet, fourth octet. Third octet multiple of 4. That's it. This is the shortcut for 1024 IP addresses. Okay, shortcut is third octet divisible by 4. Okay, and if we want 512 addresses, then third octet divisible by 2. That's it. Are you getting it?
Sir.
If we want 256 addresses, then fourth octet 0. That's it. This is the restriction. Fourth octet 0. Okay, forget about third, first, second. It hardly matters. Fourth octet should be 0 for 256 IP addresses. Okay,
Yes,
so
sir.
I hope you have got the point how we are doing it.
Sir.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
Okay. Yeah, so this is all about the restrictions and basic questions. Now we will start subnetting in classless addressing. It is also very important. Many times question have been asked. So subnetting in classful we have already done. So subnetting in classless now we are going to do. Now it's very easy because we have already done classful. So it is just like that only. Subnetting in classless addressing. Okay. Yes. So let me start the question itself. Okay. So the question is, an organization has granted with a block 130.34.12.64/26. Okay, and it need 4 subnets with equal host. It need 4 organizations with equal hosts. So directly and indirectly size of each subnet is fixed and equal. Okay, yes. So now they will ask questions like first question is total IP addresses in the block. Total IP address in block. That is very easy. 2 power 32 minus 26, 2 power 6, that is 64. Any doubt here? Yes. Any doubt?
No, sir.
Okay, because if anybody is having any doubt, then let me just say 26 ones. 26 ones means net IDs of 26 bits. So host ID will be 32 minus 26. So total number of IP addresses will be 2 power 6, that is 64. Very easy question. Okay. Second question they will ask is net mask for this range. Net mask. Net mask. So obviously 26 ones. So 255.255.255. 24 ones are consumed. Now 2 ones are needed. That is 192. So simple. This is net mask. Third they will ask for subnet mask. Okay, subnet mask. So how you will find subnet mask? We have done already class full. 4 organization means 2 bit you have borrowed. 2 bit you have borrowed means 2 ones. 2 ones you will add more. So 26 already are there. 2 1 you will add more. 28 ones. So how you will write 28 ones? 255.255.255.224. Any doubt? Yes, please let me know. Any doubt?
Didn't understand it, sir.
Come again.
Subnet mask thing. Subnet mask.
Okay, subnet mask. Okay, I have to repeat. Okay, so see this. If you try to remember, we have done this in class full addressing. What we have studied was, see this, net ID and host ID. Okay, when we have done subnetting, then we will borrow few bits from host ID part. So now this will be your subnet ID and this is the host ID. Okay, so how many bits you have borrowed? We will put one in them. Okay, so to calculate the subnet mask. Okay, yeah, so how many bits you will borrow? Because we need 4 organizations. 4 organization means 2 bit. 2 bit are sufficient to label. So 2 bit you will borrow. So already you have 26 ones in the net mask. Now 2 bits you have more borrowed. So 28 ones. So now try to write 28 ones. So 8 8 8 24. Now 4 ones you need more. So 4 ones means what it will be? 128, 64, 32 and 16. You just add them. 8 plus 4 12. So it will be 240. So I think I have written 224 previously. No? It was just a simple calculation mistake. So it is 240. Any doubt here?
No, sir. Understood, sir.
Okay, yes. So it's good. So a subnet mask is over. Now total number of IP addresses in each subnet. Okay, total IP addresses in each subnet. Okay, so there are 4 organization means 4 subnets you have made. So total IP addresses in the block were 64. So you have divided, you have given them to 4 organization. So simply 64 by 4, that is 16 IP addresses in each subnet. Okay, if you have still any doubt, you can do this way. See, total IP, 26 ones na, 26 ones means 2 power 32 minus 26. These are the total IP addresses. 4 organization divided by 2 power 2, it comes out to be 2 power 4, that is nothing but 16. Okay, you can do like this also. Anyway, whatever way you want, you can do it. Okay, and how we have divide by 4? Why? Because equal host, sorry, because each organization is having equal number of hosts. Okay, so that's why simply divide by 4 and get the answer. So 16 IP addresses is given to each subnet. Any doubt here?
No, sir.
Okay, so now very important question. First and last address of each subnet. First and last address of each subnet. Okay, so that is very simple. So now you can easily calculate it. So how we will do it? Let me jump to the next slide and then I will tell you. Take the snapshot.
Answer.
Okay, so what is the IP address? 130.34
1264.
12 and 64. Okay, so yeah, please come again.
Slash 26, sir.
Slash 26. Okay, that is okay. This is for the just to give you the idea that what are the you can say net mask. Okay, just to give you the net mask, we have given this slash 26. So now we will simply say, so first organization, for first organization, first IP address is this. Okay, and last IP address will be what? Last IP address will be so see this, because 16 IP addresses are given to each organization. So you will imagine in your head that 64 is what? 0 1 1 2 3 4 5 6. This is 64 na. So 4 zeros to 4 1 you just keep on doing it. So 4 zeros 4 1 means 15 you will add. 64 plus 15 you will get the answer. 130.34.12.79. So what about my second organization? Second organization will obviously plus 1. You just do plus 1. 130.34.12.80. If you have doubt, what you will say? 0 1. See this. For first organization, I have told you na, since 4 organizations we have taken, so you will borrow 2 bits. So this will be 0 0, then 0 1, then 1 0, then 1 1. We have already done in class less addressing. Sorry, in class full. So 0 1, then 1 2 3 4. Okay, and here we have 1 and here we have 0. So what is this number? You can check it out yourself. This is 64 and this is 16. 64 plus 16 is 80. 80, that's why I have written here. Until what point we will go? 15 you will add it. So 130.34.12.95. Okay, and third organization 130.34.12.96. Till what point we will go? 130.34.12.15 we will add it. So you just keep on adding 15, we will get the answer. Okay, so 6 plus 101. Any doubt here?
No, sir.
Okay, so what about my fourth organization? It will start with 102. So 130.34.12.102, and till what point it will go? 130.34.12.15 we will add. So 117. Okay. I have done some calculation mistake. Yeah, 96 plus 15, 111 na.
96 plus 15.
111. I have written 101. 96 plus 15 is 6 plus 111. Yes, any doubt?
No, sir.
Okay. So I have done it. So 111, then 1122, 127. Okay, so I hope you have got the point. So they can ask from in between also, what is the first and last IP address of third organization? So for third organization you will say 10. For fourth organization you will say 11. Okay, like this. So 00011011. So now it's so the basic criteria here is from where you will pick the 2 bits. That is the basic idea. Okay, so from where we have picked it. So I am not saying, you are not saying, this 26 is saying about everything. So 26 means, so first 26 bits should be constant. So in 32 bits IP address, these 26 bits will be constant. So this is from the you can say last octet. So this will be second last octet, or you can say third. This is second octet, and this is first octet. So from fourth octet we have taken 2 bits, and these 2 bits will be constant. So now we will take next 2 bits. Okay, so 0001 1011, and then we will solve it. Any doubt?
Understood, sir.
Okay, so now you can take the snapshot. I will jump to the next slide and we will solve another question.
Done, sir.
Okay, so let us suppose we have 14, 24, 40.0/22. Okay, and we want to make 8 subnets. 8 subnets. Okay, and same questions we will ask. First question is total IP addresses. Total IP addresses. Second question will be net mask. Okay, third question will be this subnet mask. Fourth question will be total number of IP addresses in each subnet. Size of subnet, I can write like this also. They can twist whatever way they want, they can twist. Size of each subnet. And the last will be I will say, see, every for 8 subnets it is it will be lengthier. So I will say first and last IP of say 5th organization. Okay, now we will try to solve these questions. So total IP addresses, that is very easy, 22. So 2 power 32 minus 22. Okay, so what will be our answer? 2 power 10, that is 1024. Okay, so and they will mention properly 8 subnet of equal size. Okay, if they have mentioned of equal size, let me write it. So if they have mentioned of equal size, only then you will follow this method. For unequal size, don't worry, I will jump to that also. We some questions have been asked in GATE regarding unequal size also. We will jump to that also. Okay, so total IP addresses is 1024. Net mask is very easy, 22 ones. So 22 ones means first 8, 8, 16, and then if I put 255, it will be 24 ones, but we need 22 ones, so subtract 3, but you will get 252.0. Any doubt?
No, sir.
Okay, subnet mask, so 8 subnets na, so you will borrow 3 bits. 3 bits borrow means 25 ones you will get. So what is the value of 25 ones? 255, 255, 255.128. Is it okay now? Size of each subnet, that is also very easy. So from proper, what we will say, 2 power 32 minus 22. These are the total number of IP addresses, and divided by 8, divided by 2 power 3. So 2 power 10 divided by 2 power 3, that is 2 power 7 IP addresses. So size of each subnet is 2 power 7. Okay, yeah. Now what they are saying, first and last IP address of 5th organization. So what do you mean by 5th? For first, or see, now you have borrowed 3 bits. 3 bits na, so 000 for first organization, so 1 less na, so for 5th organization it will be 100. Now question is from where these 3 bits will be borrowed. Okay, so I will say, see, this 1424 first 2 octets properly done, and then from the third octet, what we will say, 22 you have taken 22. So that means what, if we take 24, then 40 will be fine, but we will not take you can say 24 bits, we are taking 22 bits. Okay, so 22 bits means last 2 bits we have taken. Okay, so last 2 bits of this third octet, and first bit of last octet. So these 3 bits you have borrowed. Please let me know if you have any doubt. I have just labeled it. Do not say that these are ones. I am just labeling it. Okay, so let me put the dash. So 2 bits from the second octet, and first bit from the 2 bits from the third octet, and 1 bit from the fourth octet. Please let me know if you have any doubt.
No, sir. Understood,
Okay.
sir.
So very good. So 22 ones were there. So this untouched from here till 6 bits you have
Yes,
taken. So last 2 bits and 1 bit from the last octet. Okay. So now I will put what 100 here. 100 here. Okay. And then we will try to find first and last address. So what will be these 6 bits? So you have to calculate binary of 40. Now I cannot do directly. I have to find binary of 40. What is the binary of 40? 40 is 1010 1010 then 00. Okay. So now these, but we have taken from 00, we have made it 10. Okay. So 4, 5, 6, 7 and 8. Okay. If you have any doubt, I can do it like this also. See, I will say what is the binary of 40? 10 10 10 0 20 40. This is 1 2 3 4 5 6 7 and 8 8 bits. So this is the story of your third octet. Now from this third octet you have borrowed these 2 bits, and from the last octet you have borrowed one extra bit. So these 3 bits you will you will revolve. Okay. So for fifth organization, what you will say here 10 and here also 1. So now try to see what is this octet now. So 14.24 dot. So if entire thing was if these two were 0, then 40. Then this one means 2 you have added. So 42 42.0. Okay. Until what point we will go? 14.24.42 dot last 7 ones. Last 7 1 means 127 127. This is my answer. Yes, if you are facing any difficulty, please let me know. Any doubt?
Sir. That 42 that we got.
This is the problem. Okay, so let me tell you 1 0 0 1 0 1 0. If they were 0 0, this is 40. This is the 40 binary, na? Now, if I put here 1, so what is the weight of this place? 2. So 40 plus 2, that is 42.
Yes, sir.
Okay, so if you have doubt, you can see like this also. This is 10. 1010 is 10. After 10, 1 means 21.
Yes, sir.
If 0, then 20, then plus 1, 21. 21 into after 0, then 20. 21 into 2, 42. 42 is our answer.
Yes, sir. Yes, sir.
Okay, and no need to do these lengthier calculations. You just think about it. If you have 0 0, you put here 1, it will become 2. That's it. So we have done like this. So I think it's okay. Actually, some children are playing with crackers outside. So you are facing any difficulty in my audio? Or it's okay.
It's okay, sir.
Okay. Yeah. So fifth organization we have done it. So now we can say about what about say, if you want any organization, say I will say third organization or fourth organization. Fourth. Okay. Third we should do, because fifth is very fourth will be easy. Third organization. So third means what?
0 1 0.
Third means 0 1 0. Yes, very good. 0 1 0. So you just find it out. What will be 0 1 0? So I will try to write directly. Okay, if you are able to imagine, then it's fine. Otherwise, I will give you the reason. 14.24.41.0 to 14.24.41.127. Facing any difficulty?
No, sir.
Okay, so you just put here 0 1 0. 0 1 0. Okay, so 0 1. So means if both were 0, 1 0 1 0 0 0. If both were 0, it is 40. If you put here 1, it is simply 41. So 41, that's it. Okay. Yeah. So it's all up to you how you build your speed, how you do the practice. The more you do the practice, the more you will get it. Okay, it's as simple as that. Yeah. So take the snapshot, and if you want to give, should I give any other organization, or is it's okay?
No, sir. It's okay. We'll practice.
Okay. So in homework, try to find first and last of each organization. You will get more clarity. Okay. first and last of each organization. First and last of each organization. So how you will attack the question? The basic attacking is you just try to find 8 subnets. It's okay with me. 8 subnet means 3 bits. Now from where you will borrow 3 bit, that is the basic question. If you are able to answer that question from where we are going to borrow 3 bits, game over. Okay, very very simple now. And how you will find it is very easy. 22 na 22 ones are there, so you will borrow 3 bits after 22 bits. Okay, so you just check where 22 bits will end. 8 bits, and from here you will take 6 bits. So here 22 bits are over, so rest bits are with you. So now you will borrow 3 bits from here. So 1, 2 and 3. So last 2 bits from the third octet and 1 bit from the fourth octet, and then you will keep on revolving and get the answer. Very simple. Okay, so yeah, take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So I think now it's these questions are very trivial, and just for the sake of completion, I will solve just one more question. 14.40.0.0. Okay, and let us make it a bit trickier one. Let us suppose I take 128 dot or 192. Okay, 192.0 slash 16, 17, 18 slash 20. Okay, let us take this slash 20, and now I am saying divided among 16 organizations. 16 organizations. Okay, so the first address, total IP addresses and so on, that is very easy. If you say total IP addresses, that is very very trivial. 2 power 32 minus 20, that is 2 power 12. It comes out to be 4096 IP addresses. That is very trivial. Total IP addresses, okay, and 16 organizations, so size of each subnet and so on, you can calculate very very easily. And now I should do a very you can say typical kind of question. Okay, so I will say first and last IP of 13th organization. How we will do it? 13th organization. So I will say since 20 bits. So first try to bifurcate 20 bits. Okay. So 14.40. Okay. Dot. I will simply say 16 bits are over. Okay. Now 20 bits. Now so 4 bits you will take. So 4 bit means 1, 2, 3, 4, 5, 6, 7, 8. Let me draw it properly. No problem. Here it will be 0 only. So from here I will say these 2 are 1 because of 192, and these 4 like this. This is 20 bits which are fixed. From here you will borrow these 4 bits. Okay, let me use another color for your you can say subnetting. Okay, 16 organization now. So 4 bit you have to borrow. So I will say third octet last 4 bits you have borrowed. Okay, yeah, and now I will say what. So 192 was there, so obviously binary will be here 0 0, and here also all 0 0. So now these from all zeros to all ones we will do. Now since I want 13th organization, 13th means 1100. Now just put the value and get the answer. That is very easy. So now I will say 14.40.1100 and then 1100. So this double means 12. So 192 plus 12. You just do it. 192 plus 12 is 192. 204.
204.
204.0. Okay, until what point we will go? See this. So now these 4 are also fixed. So these will go from all zeros to all 1. So 14.40.204.255. Any doubt here?
Nice, sir.
Okay, so now you can do any type of question like this. So it's more than sufficient. Okay, so now everything we have done till in subnetting, we have assumed equal size subnets, but it is not always true. It depends on need of organization. Some organization might need you can say different size subnets. Okay, so let me tell you that also. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so first of all we will try to answer very basic questions which have been asked in GATE, and then we will dig deep into it. Okay, so question is saying an ISP has granted a block 190.100.0.0/16. Okay, and it need to distribute these among three groups of customers. We have three groups of customers. Okay, this block has been given to an ISP, and now this ISP wants to give IP addresses to three group of customers. So first group is, we have 64 customers, and each need 256 IP addresses. Second group is 128 customers, and each need 128 IP. Third group of customer is say 128 customers, and each need 64 IP. Okay, so now basic question is wastage. Please tell me how many IP addresses are wasted. How you will calculate it? That is very easy. See this. Total IP addresses are how many? Upon /16. /16 means 2 power 32 minus 16. That is 2 power 16 are the total number of IP addresses in this block. So ISP has got 2 power 16 IP addresses. Okay, now it is dividing these IP addresses into three groups of customers. So 64 customer and each need 256 IP addresses. So first group needs how many IP addresses? 2 power 6 multiplied by 2 power 8, that is 2 power 14. Any doubt here?
No, sir.
Okay, next 128 customer, each need 128 IP addresses. So 2 power 7 into 2 power 7, that is again 2 power 14. Next 128 customer, each need 64. So 2 power 7 into 2 power 6, that is 2 power 13. So total number of IP addresses given is 2 power 14 plus 2 power 14 plus 2 power 13, and how many it was having? 2 power 16. So wastage is 2 power 16 minus 2 power 14 plus 2 power 14 plus 2 power 13. Any doubt?
Understood, sir.
Okay, so now how you will solve it? That is again very easy, no problem. So you just try to do it in smaller power term. 2 power 13 is the smallest power here. So I will say 2 into 2 power 13 is 2 power 14. 2 into 2 power 13 is 2 power 14. So 2 plus 2 plus 1, that is 5. So it is nothing but 5 into 2 power 13. Any doubt?
No, understood, sir.
Okay, and what about this? This is nothing but 8 into 2 power 13. So 8 minus 5 is 3.
3.
So 3 into 2 power 13 IP addresses are wasted. That's it. Okay. Yeah.
Yes.
So you can take snapshot of this. Then I will jump to the next slide, and I will try to show you how this will be done. Okay. So what are the first address, last address, and so on. How it will be done. Let me tell you that thing.
Done, sir.
Okay, so I will say total IP addresses with us are 2 power 16, and what is the starting address? 190.100.0.0/16. So this is our organization. So 190.100.0.0/16. Okay, this is the total number of IP addresses which this router will handle. So now I have to divide it into 2 power 14, 2 power 14, 2 power 13. So how you will divide it? So I will say, since I need, are you getting it now? First group is 2 power 14, second 2 power 14, third 2 power 13. So 2 power 14 you want. So 2 power 14 means total 2 power 16. So 4, you will get 4 subnets. Okay, each will be having 2 power 14 IP addresses. This also 2 power 14, this also 2 power 14, this also, and this also. Okay, so yeah, so how you will label it? So I will say 190.100.0.0/16. Here I will say, I will repeat it, 190.100.0.0, but slash I will write 18. Why I have written 18? Because we are doing now subnetting, na? So this will apply subnet mask, na? Are you getting it? Okay, so you do not worry if you have any doubt. I will clear your doubt, but first let me complete this how we will divide it. Okay, and it is not very difficult. It is very easy. So you just try to focus here what we are doing. 190.100.0.0/16. This means what? Total IP addresses are 2 power 16. This router is handling 2 power 16 IP addresses. This router is going to handle how many IP addresses? 2 power 14. So how you will see 2 power 14? 190.100.0.0/18. Slash 18 means it will handle 2 power 14 IP addresses. Why 2 power 14? 2 power 32 minus 18. 32 minus 18 is 14. So it will handle 2 power 14 IP addresses. Now what about this? So now you just forget everything. You just tell me this this block is divided into 4 organizations. Okay. So this is first address of the first organization. And what will be the first address of this organization? So you have borrowed 2 bits na, from where? This octet 16 na. So first 2 bits of this octet you have borrowed. Please let me know if you are facing any difficulty.
Yes, sir.
So what I will write here? I will write here first this will be 190.100.64.0/18.
Yes.
Any
Sir.
doubt here?
No.
So here what will so here 00, 01, then 10. 10 means 128. 190.100.128.0/18. And here 11. 11 means 190.100.192.0/18. /18 means how many IP addresses this router is going to handle? This router is going to handle 2 power 16. This router is going to handle 2 power 14. So 32 minus 18 is 2 power 14. That's why we have done this. Okay. So now this 64 customer each need 256 IP addresses. So now this will again divide this block into how many how many were there? 64 customers. So 64 it will divide. Are you getting it?
Sir.
So these will be 64. Okay. So now please tell me how many IP address this router is going to handle. Just divided by 64. So total 2 power 14 IP addresses were there, and by the way we have here 256 IP address each, and you can calculate from here also. 2 power 14 divided by 2 power 6, that is 2 power 8, that is 256. So each router is going to handle 256 IP addresses. 256 means 2 power 8. So 32 minus 8 it will be 24, or you can say 18 plus 6, that is also 24. So I will write here first address will be 190.100.0.0/64/24. Please let me know if you have any doubt here. Any doubt?
No, sir.
Okay, so good. Gate questions, these are gate questions only. Okay, so try to focus here. I'm solving each and everything. They will ask from in between. Okay, so don't worry. So next, this let us suppose this is our first organization. This is suppose second. So from where second will start? That is very easy. 190.100 last 8 we will follow na. So .1.0 and here 2.0 and so on. So till what point we will go? 190.100.63.0. So these are the first addresses of 64 organizations.
Yes, sir.
Are you getting it or not?
Understood, sir. Yes, sir. Getting it, sir.
Okay. So and first organization last IP address, that is also
/24 for all these addresses also, no, sir.
/24, just to tell you that this block contain total 2 power 8 IP addresses. That's why. Yeah. And till what point we will go from here? Last address will be 190.100.0.255. That is very easy. How I have calculated it? Because 2 power 8 IP addresses now. So 8 zeros to 8 1. So this octet we will move. So very easy now. Okay. So 0 to till 255. From here 63.0 to 63.255. Now see this 60.255. You just add 1. You will get this. So now we will jump to the this second organization or second group of customers. Any doubt here till now?
No, sir. Understood.
Okay, so now next is 128 customer, each need 128 IP addresses. So now what we are going to do? Now this router or this organization has divided into total 128 organization. This was the 64th organization, so this will be 128th organization. So first organization, second organization, and so on. Okay, and each need how many IP addresses? 128 IP addresses. So from where we will start? So please see this 190.100.0.0. So here also this router, this organization is also getting 190.100.0.0, but here /16, here /18, and here also this 190.100.0.0, but here /24. Same IP address was going. Okay, but here /16, /18, /24. Okay, so now here what we will say, so first organization, the same IP address only. Okay, but each 128 organizations we have taken. So how many IP addresses is having? 2 power 14, and we have divided them among 128 organizations. So what will be our answer? 2 power 7 only. And this is the same here, what we have said, 128 customers of 128 IP addresses. So first customer or first organization, first and last try to find. So first IP address will be 190.100.64.0 /18 plus 7. It will be 25/25. Any doubt here?
No, sir.
18. This was 18, and why I have added plus 7? Because each organization need 128 IP addresses only. Okay. So /25. So now till what point it will go? Okay, I think it is becoming messy. So let me take it. It will create problem only. So where should I write? Okay, so it's okay. We have written here. Last IP address I will write here. What will be the last IP address? 190.100.64.127. Any doubt here? Because last 7 bits we will revolve. Okay, yeah, and this second organization from where it will start? 190.100.64.128. Okay, until what point it will go? 190.100.64.255. Any doubt?
No, sir.
Okay, and what about my last 128th organization? What about 128th organization? So it will start with 190.100. What about 128th organization? It means last. See this. So in the third octet, you have borrowed how many bits? 7 bits you have borrowed. Okay, see this. 190.100. Okay, because it was /18 already, so you have borrowed 2 bits from here. You have already borrowed. Okay, and what we have put here? 0, 1. Why? Because 64. Okay, and now from here onwards you have borrowed 7 bits. So 6 bits you will borrow from the third octet, and 1 bit you will borrow from the fourth octet. 6 bit from here, 1 bit from here. And 128th organization means 127 you will fill here. So 1, 2, 3, 4, 5, 6, and here's 1, 7. Please let me know if you have any doubt here.
I got it, sir.
Okay, yeah. So this was first octet, this was second octet, and in third octet, 64 was already there because /18 was there. Okay, and then we have borrowed 7 bits, so 6 bits from here and 1 bit from here. Okay, so what will be our answer? 190.100. What about this? 127.128. Until what point it will go? 190.100.127.255. Okay, to check you have done correctly or not, you just add 1 here, but we will get this only 190.100.128.0. Okay, so from here third organization will start. Okay, yes, so third organization is, needs 128 customer each needs 64 IP addresses. Okay, so 2 power 13 IP addresses basically it need. Now try to see here carefully. Again, I have to divide it. Okay, so what I will say, I will divide this into two parts. Okay, so what are these? I will divide here into two parts. Okay, so what I will get here, this will be 190.128.0/19, and here also /19. So let me write it. Where should I write? That is the big problem of space. So let me put it here. First part and second part. First part will be this will get what, 190.100.128.0/19. Why I have divided it? I think you have got it. See, we need 2 power 13 IP addresses. Total we need 2 power 13 only. But how many we are having? 2 power 14 we are having here. This router can handle 2 power 14 and we need only 2 power 13. So it's better we first divide it into two parts, 2 power 13, 2 power 13 each. Okay, and then this 2 power 13 will be divided further. So okay, so here what will be the first address here? 190.100. So 1 bit you have borrowed now. So 1 bit borrowed means 18 was already, so that means what, 2 bits were there, so this will become 1. So 128 plus 32, what will be that? 128 plus 32,
160.
160. Yes, 160.0/19. Please let me know if you have any doubt.
Understood, sir.
Okay, so /18 we were already having, so we have just borrowed 1 bit. Okay, 128 was already there. Try to just visualize 1, 2, 3, 4. This is third octet. Third octet, first bit is already 0 because of 128. Okay, and 110, this is fixed because 2 bits are already fixed. So 8 bits, 8 bits, and 2 bits. Okay, 16 plus 2, 18. These are already fixed. Now 1 bit you have borrowed. So 1 bit means 0 or 1. So if you put here 1, what you will get here? 128 plus 32. 128 plus 32 is 160. That's why I have written here 160.0. Okay, yes. So now it's up to you. It's your choice whether you divide this or you divide this. It's your choice. Okay, so I will divide this. So divide this into how many customers? 128 customer, each needs 64 IP addresses. So now you can divide it into 128 customers, each need 64 IP addresses. 64 IP. So you can calculate like this also. Since each customer needs 64 IP, so 64 IP means 6 bits. So 32 minus 6, what you will get? 32 minus 6, 26 na? Na? So /26 we will do. Okay, so I will say first organization IP will be 190.100.128.0/26. Okay, and till what point it will go? 64 IP addresses now, so till 128.63 and so on. So can you do it?
Sir.
Okay, so this part, this is completely wasted, that is 2 power 13 IP addresses, and this part completely wasted, that is 2 power 14 IP addresses. So this is wasted. So 2 power 13 plus 2 power 14, that is 3 into 2 power 13. This is the wastage. So last here and here, these are wasted. Okay.
The last is also you have written like /18. That's why 14. Correct, sir. Sir.
Yeah. बिल्कुल ठीक 18, so that's why 2 power 14. Yes. Okay, so this was the one of the very difficult question. Okay, if you are able to solve this by hook or by crook, then you can solve any gate question. Okay, so and let me give you a very simple question, okay, which you will be able to manage very easily. Let me tell you that also. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so if you have any doubt here, you can ask me, and if you can watch the recording also. After watching recording, if you have doubt, you can ask me any problem here. Okay, but you have to grab it properly. If you are able to grab it properly, then you can solve any gate question. Okay, let me jump to the next slide now. So we have a block with the IP addresses say 36.46.56.0/24. Okay, and it has been divided into three groups. Okay, so first group need 120 IP addresses, second group need 60, and third group need 10 IP addresses. How we will do it? So again, different. Okay, so we want to divide it into three groups, and both all need different. So if someone need 120, what you will give? 128. If somebody needs 60, you will give 64. If somebody needs 10, you will give 16, because 2 power. Okay, now /24 means how many IP addresses are there? 32 minus 24, that is 2 power 8 IP addresses. Okay, so these 2 power 8 IP addresses, okay, you want to divide 128, then 64, then 16. So it's very easy. So just by common sense we will do it. So what we will say, this is the router, okay, and this complete block is assigned to this router will manage this complete block. So 46.56.0 /24. Okay, this is going to manage this entire block. That means 2 power 8 IP addresses. First group need 128 IP addresses, so you will divide it into two parts. 128 each. So now it's up to you. It's your decision which part you give to which. Okay, so you can, yeah, this is the organization A, this is organization B, this is organization C. So you can give this entire block to A, or you can give this block to an organization A. So both options you have to check in GATE exam. Okay, so if MSQ question is coming, they can ask you both also. Okay, so you have to be careful, very careful. So how we will start? I will say 36.46.56.0/25. Why 25? Because I have divided into two parts only. One bit I have borrowed. And here what I will put? 36.46.56.128/25. Please let me know if you have any doubt.
Understood, sir.
Okay, because /24 na, so 8 bits. 8 bits, so one bit you have borrowed. So fourth octet, first bit you have borrowed. So first bit 0, that is all 0. First bit 1, that is 128. Very easy. Okay, so now you just give this to organization A. I am assuming this thing. You just give this to organization A. So now what you want from here? So how many IP addresses are with this? 2 power 7. And how many are with this? 2 power 7. So 2 power 7 you have given to organization A. Now these 2 power 7, what we want? 64 to the organization B. So I will again divide it into two parts. This and this. So this part I will say 36.46.56.128/26. One more bit you have borrowed. Okay. So and here what we will say 36.46.56. Now one bit you have one more you have borrowed. So so it will be 192/26. Please let me know if you have any doubt. Facing any difficulty? So let me tell you that thing. See this 1, 2, 3, 4 octets. So first octet 36 copy paste, second octet copy paste, third octet copy paste, fourth octet one bit you have already borrowed. Okay, and you have put it one here. Okay, that's why you have got this 128/25. Now one bit again you have borrowed. Okay, and here if you put 0, it will be 128 itself, that is /26. Now if you put here 1, what you will get? After that we have 6 zeros. So first two bits 0, 128 plus 64, that is 192. That's why 192. Any doubt here?
Understood, sir. Nice, sir.
Okay. Yes. So now it's your choice whether you give this to organization B or you give this block to organization B. I'm assuming I'm giving this. So let me give this to organization B. Okay. So now this organization C needs 16 IP addresses only. So how many IP addresses we are having here? 2 power 32 minus 26, that is 2 power 6 IP addresses. That means 64 IP addresses. So I will say organization B has got 2 power 6 IP addresses. Now these 2 power 6 IP addresses, and you want only 16. So 16 into 4 is 64. So you will divide it into 4 groups. Okay. And it's your choice, whatever group you want you can give to this organization C. So I will take this. So what IP address it will be? Very easy. 36.46.56.192/28. Please let me know if you have any doubt. 26 and plus 2 na, because 2 bits you have borrowed, /28. You can give this to organization C. Okay. And if you want to give this block to organization C, you can give that also. So how you will start? uh, two bits you have two more bits you have borrowed. Okay, so double one was there. If you put double zero, you will get 192. If you put 01, what you will get? 192 plus, see this, these are 4 zeros, this is fixed. Okay, so what this will be? 01 means 1 power 1 followed by 4 zeros is 16. So plus 16 you add plus 16. So 192 plus 16. So it will be 208. So you can give this also 36.46.56.208/28. Any doubt?
No, sir.
Okay, now similarly you can give 10 also and then 11 also, and you can find this also and this also. Okay, very easy now. So it's up to you, whatever way you want you can take it. Okay, so one way I have shown you. In GATE exam they can flip it also. Flip it means, so they can say which of the following IP address is valid IP address for first or for organization A. So you will say this is the valid. Okay, because we have given this to A. Now if they say they give this block to organization A, then entire this part will be shifted here. So you just rotate it. Okay, so I can give like this also. So this you give to organization A. Now you will divide it into two parts. This you can give to organization B, and this you divide it into 4 parts. And now it's all up to you, whatever part you want you can give to organization C. Like this also you can do. Okay, so for A you can take this IP address also. Okay, so there are many answers for this question. So they will give 2 to 3 options which might be correct for MSQ. Okay, so this is for sure. If they are talking about organization A, you have to see /25 only. Okay, /25, that is the best way to see for organization A, because /25 means 2 power 7 IP addresses and organization A needs 2 power 7 IP addresses only. Okay, so you will simply cut /26, /28 and so on. You simply cut them. You simply say /25 and /25. Only 2 options are there for class A, that is 0 or 128. Is it okay?
Yes.
And for class for organization B, you will say /26 should be the option. Whatever option is /26, you will see and you will try to imagine whether it is possible to give to class B to organization B or not. Okay, so you can see either 128 or 192 with /26. Okay, if you are taking from here, entire scenario will change. Okay. Yeah, so there are many answers for this question. Anyway, I'm not digging deep into all these things. You have got the idea, that is more than sufficient. So you can do practice and you can find other ways also. Okay, so and this is homework. Okay, try to do it. First address, last address for organization A, and if I give this, then you have to find first and last for organization B, and if I give this to C, you have to find first and last. Okay, similarly other possible ways can be this. So you can give this to A, Okay, and you divide it into two parts. You give this to B, and this you divide it into four parts, and you give this to C. Are you getting it or not?
We're getting it, sir.
Okay, so there are many ways. I think you have got it. Okay, so there are multiple ways you can find that out, and you can do these things. Okay.
Yes, sir.
Yeah. So that's it. So you can take snapshot of this, and this is all about your class less addressing. I hope you have got it. Now you can check out all the gate questions. If you find any question as difficult, I will solve that also. Okay, so you can ask your doubts and all in WhatsApp or anywhere, because I am saying I am stressing this topic because it is most important topic, most important for gate. Every year you will find 2 marks question from this IP addressing topic. Every year 2 marks. Okay, so this is that much important topic. So try to solve all of them. If you have any doubt, you can ask me. Okay, now let me jump to the next slide. You can take the snapshot.
Done, sir.
Okay, so now IP addressing is over. Now we are going to start some special addresses. There are some special IP addresses. Okay, so what are these special IP addresses? Let me tell you that. Special means they are reserved. Reserved means not given to any computer. Not given to any computer connected to internet. Okay, so there are some IP addresses which are not given to any computer which is connected to internet. Okay, that means directly and indirectly internet will not recognize these IP addresses. That is the basic meaning. So let me tell you that thing. So the very first IP address is 0.0.0.0/32. So how many IP addresses are there in the block? You will say 2 power 32 minus 32, that is 2 power 0, that is nothing but 1. So only one IP address. This is only one IP address. It is not a collection of IP addresses. Okay, so why this address is used? So if machine does not know its own IP address and it wants to send an IP datagram, then it will fill this as source IP. See this, if you want to send any packet, any datagram, then obviously you should have an IP address, but you do not have any IP address and still you want to send the packet, then in source IP address you will fill this. Okay, and how you will send it and why you need it and so on, don't worry, I will tell you about that thing later. Okay, we will study few protocols, in that I will tell you. Okay, and just for the sake of, you can say, if you want, just for the sake of formality, I can say like this. This question, by the way, has been asked in gate. So diskless machine, diskless machine means it is not having any hard disk. Diskless machine is just booted. Okay, and it does not know its own IP address. Obviously, how it knows IP address? Because it has just booted. So now it wants to know its IP address. Okay, so it will send an IP query packet to the server regarding, please let me know my IP. So if it wants to send an IP datagram, then obviously it has to fill the source IP address. That means who is sending the packet. For example, you send letter to somebody, you put your own address into that, so that he or she can reply you. If you do not put that address, then mailing system will ignore that mail. Okay, or letter will be ignored. Letter will not be sent to the respective person because you have not written your own address. That is the basic necessity. So that's how here also I will say diskless machine has booted and it wants to know it does not know its own IP. So it wants to know its own IP. It will request to the server, please let me know my IP. So it will, in source IP, it has to find, it has to fill something. So it will fill 0.0.0.0. Okay, so that is the basic use of this special address. Okay, so obviously it will not given to any machine or something. So please write it. If machine does not know its own IP address, if machine does not know its own IP address and it wants to send an IP datagram, if machine does not know its own IP address and it wants to send an IP datagram, and it wants to send an IP datagram, then in source IP address it will fill, then in source IP address it will fill all zeros. then in source IP address it will fill all zeros, that is this only. Okay, all zeros, that's it. Okay, yeah, so you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so next IP address is 255.255.255.255/32. Again, only one IP address. Okay, how many IP addresses are in this block? 2 power 32 minus 2 power 32, 2 power 0. That means only one IP address is there in this block. Okay, and now why this is used? First of all, let me tell you that thing. This is known as limited broadcast address. Limited broadcast address. I have already told you DBA, direct broadcast address. Okay, what was the use? Direct broadcast address was used to send packet to a particular LAN. You are here in this LAN and you want to send packet to each and every computer in this LAN. You will use DB of this LAN, direct broadcast address of this LAN, and you will be able to broadcast the packet directly to this entire LAN. Now, what is limited broadcast address? Limited broadcast address means you are in this LAN and in your own LAN you want to send packet to each and every computer. For that you will use this all ones, that is known as limited broadcast address. That means you can broadcast packet in your own LAN. Okay, why we are calling it limited? Because its scope is your LAN only. Okay, because the moment see this this LAN is connected to internet by this router. Okay, so this is your entire internet. Let me write it properly. This is your entire internet, big, and this router is connecting your LAN to this internet. So now this computer A has specified in destination IP address as all ones. Destination IP address is all ones. All one means 255.255.255.255. Okay, so now if destination IP address is all ones, then all the receivers or all the computers in your LAN will receive the packet. But the moment it reaches the router, router will drop the packet. Can you guess why router has dropped the packet? Because if this router forward the packet, then this packet will move in entire internet. And if it moves in entire internet, then it may lead to congestion in entire internet, because everybody now, if this router allow, then you are an ad agency, you have your product and you want to promote it, you will send promotion to each and every computer in this internet. Promotion will be very easy, and if it is very easy, then everybody will do the promotion and entire internet will fall down. Okay, entire internet will be congested. So that's why they have made a rule that if all ones are there in destination IP address, router will drop the packet, or no packet having DIP all one will be able to cross any router. Immediately router will drop it. Is it okay?
Yes, sir.
Okay, so that's why it is known as limited broadcast address, because it is limited to your LAN only. Okay, it cannot cross your LAN, because if it can cross your LAN, it can cross any LAN in the internet, and then it will create very big problem. Okay, so so you can write one line. This address is used to broadcast IP datagram in your own LAN. This
Done.
address
Wrote it, sir.
done. Okay, note down that. Okay, then it's good. Okay. Yeah, so you have written that point also. Whenever DIP is all ones, then router will drop the packet.
Yes, yes.
Okay. Yeah, so next is third. Let me tell you that take the you can take the snapshot.
Done, sir.
So third special address I am telling you is 127.0.0.0/8. How many IP addresses are these? 2 power 32 minus 8, 2 power 24 IP addresses. So this block is having 2 power 24 IP addresses. and this is known as loop back addresses. These are known as loop back addresses. So loop back address means whenever destination IP address is this, then packet will never leave the machine. That means this is your computer, okay, and you want to if destination IP address is this, then your packet will never leave your machine. That means this is the wire. It will never come to this wire. It will loop back to your own computer. Okay, so it will never cross your machine. It will come back to your machine. That's why we are calling it as loop back address. Loop back addresses. So what is their use? So they just want loop back address means you just want to check that whether your IP protocol is able to create datagrams and receive datagram properly or not. That means for network diagnostic purposes we are using this. Okay, so it is basically used to test the IP software. That means your IP software is creating packets properly and receiving packets properly or not. That's why you will use these addresses. Okay, so you might argue with me, sir, why you have used these addresses? Okay, so you in SIP obviously you will put your own IP address. For example, your own IP address is 140.40.60.70. okay, and in DIP you will fill this, say 127.0.1.0, whatever way you want you can put it, because /8 na 2 power 24 IP addresses are there. 2 power 24 means these three can rotate from 000 to 255 255 255. So I just put here 127.0.10. So if datagram is having SIP is this, that is your own IP address, destination IP address is this. So now this packet will never leave your machine. So you might argue, sir, why we are using it? It's better that we keep in destination IP address is the same IP address only. Okay, so packet will come back to you only. But if you put destination IP address as this same IP address, it will leave your machine. It will go here and there, and it will come back to again to your device. What is the use? Why you are creating trouble for routers and all, and they will forward the packet back to you? Okay, you just want to check your IP software is doing sending or receiving packets properly or not. So why you are troubling others? You can do yourself also. That's why we have used this loopback addresses. So basic idea is whenever destination IP address is 127, let me write it, 127.x.y.z. Okay, any value, XYZ can be 0 to 255, any value. Okay, if destination IP address is this, then packet will never leave the machine. That is the important point. Okay, it will never leave the machine. That means it will never go out of the machine. That is the basic meaning. Okay, so you just write one or two lines. It is used to test the IP software. It is used. Okay. It is used to test the software, and whenever destination IP address is this, then it will never leave the machine. Okay. Yeah, and one more important thing, ping command. Ping command can use this if you know ping.
I know that.
In command prompt we can write ping. So if you write ping 127.0.0.1 like this, then it will check. It is the utility. It will check your IP software is working properly or not. Okay. Okay, so it is for check to testing or debugging your IP software. Okay, next, fourth, I am jumping to that. Take the snapshot.
Done, sir.
So fourth is some private addresses. There are some private addresses. Okay, so what are these? So first is 10.0.0.0/8. Next is 172.16.0.0/12, 192.168.0.0/16, 169.254.0.0/16. These are the four set of IP addresses, rather four blocks of IP addresses, which are known as private addresses. Private addresses means internet cannot recognize these IP addresses. Okay, internet router will not recognize them. So how many IP addresses are there? 2 power 32 minus 8, it comes out to be 2 power 24. Here 2 power 10, so 2 power 20, 2 power 16 and 2 power 16. So there are very large IP address, 2 power 24, 2 power 20, 2 power 16, 2 power 16. Add them, you will get the answer. These are the total private addresses. And I think you have used it, 192.168.0.0.
Mm.
0.1 if you put, you will be able to see your router configuration. You can change the key of your router and so on, whatever you want you can do it. So 192.168.0.1, okay, we can use it. So these are all private addresses, okay, these are not you can say recognized on internet. Okay, so why these are useful, let me tell you that also. Take the snapshot, I will jump to the next slide.
Done, sir.
Okay, so you might say you have only one router at your home, so only one IP address is given to you. For example, it IP address given to you is 200.20.30.40. Okay, now with this router, or if you have wireless router or something like that, you are able to connect your mobile phone, 2 or 3 laptops, 1 or 2 computers. So how all these devices are able to communicate? You have only one IP address, and I have told you, if some computer wants to connect with the internet, then it must have an IP address, but only one IP address is there. How these 4 or 5 systems are able to connect with the internet? The reason is these private addresses. Okay, so this router will assign each of you some private address, and if you have done work on LAN or something, so manually we assign 192.168.0.1 and then 192.168.0.2 and so on, like this we will assign. Okay, let me copy it. Okay, so here I will say dot 2, dot 3 and dot 4. Okay, so total 4 computers are there, and I have this router has assigned these private IP addresses to these. Okay, so for example, this computer wants to send some you can say packet to internet. So obviously what it will do, in SIP it will fill this. Okay, 192.168 like this. In SIP, oops, in SIP it will fill it 192.168.0.1. In DIP it will fill whatever IP address it want to send packet, and it will send it to router. What router will do? Router will make an entry here. It will say 192.168.0.1 wants to communicate with some IP address, say 230.60.70.80. Okay, it will make an entry like this. And now what it will do, obviously internet cannot recognize this IP address, so it will extract this IP address and put its own IP address to the packet and send it to the internet. Are you getting it?
Internet in the sense the LAN itself, sir? Or
No,
internet?
entire internet. So you are in India and you want to communicate with some person in USA, okay, or somewhere in the world. So, and you know its IP address. If you want to communicate with some computer, then you should know its IP address. That is the rule. If you do not know IP address, you cannot communicate. So you know the IP address of it. Okay, so like you, and I will tell you in application layer, like you type www.google.com. So you just know this, but actually this is converted to IP address internally with DNS, domain name system. Okay, so directly and indirectly, this is the rule that you should know IP address of the computer to which you want to communicate. So I'm assuming that you know the IP address of the computer to which you want to communicate. Okay, so you have type in that IP address. So SIP and DIP. Okay, you will fill it, and you will send the packet to the router, because you are connected to this router only. You have to send the packet to this only. Now this router, what it will do? It will remove this SIP and put its own SIP here and send the packet to the internet, to other routers and so on, and they will finally reach that computer. And whenever that computer will reply, this router will check the table. that okay, so to this IP address this this was communicating, so it will send the packet to this computer. Any doubt here?
No, sir.
Okay, so it's the game of this router only. So what it is doing, it is simply replacing SIP of the given it is simply replacing the SIP private SIP with its own SIP and sending packet to the internet. Why it is replacing? Because this SIP is not recognized on the internet. Okay, internet router will not recognize it. That's why they it will send this IP address. Okay, so it will replace this by this, send packet to the internet. Obviously internet will reply to this only. Okay, now router will receive it and it will check the table which computer was communicating with this IP address. So it will send packet to that system. Okay.
Yes.
So if any other computer wants to communicate, then any other computer will send it. It will send to the internet and it will reply and so on. You keep on doing the things. Okay, it will simply make table and put entries and so on. So the procedure which I have told you, this is known as network address translation.
So it's
Network address translation. Network address translation or NAT. Yes, any doubt here?
nice, sir.
Okay, okay then. Let me jump to the next slide now. So next address, so how many we have done? 4. Fifth special address now I'm going to tell you. Fifth is multicast addresses. Multicasting is not in GATE syllabus, that's why I'm not going to tell you how multicasting is done and all. Multicast addressing, I should say multicast addresses because I'm telling you the list. So that is 224.0.0.0/4. /4 means 2 power 32 minus 4. 2 power 28 IP addresses are reserved for multicasting. Okay. Yeah, this is all about it. We will not dig deep into multicasting, how it is done, because it is not required for GATE. Yes, you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now we are in position to start our IP protocol. IP addressing is over. Now we are going to start IPv4 protocol. So just to revise, we have already done, but I will tell you a few basic points which are very, very important regarding IP. IP is unreliable and connectionless protocol. Unreliable. In first or second class we have done these things now, but I'm telling you again because these are very important. Unreliable and connectionless protocol. Unreliable means there is no error detection or correction here, and connectionless means no connection is established, or there is no mind makeup, or there is no allocation of resources and so on. Okay, so it is unreliable and connectionless. Okay, and its aim is, why it is unreliable and connectionless? Because its aim or its entire focus is on sending packet only. That's why it is known as best effort delivery system. It is known as best effort delivery system. Okay. So, and IP transport fixed length packet or variable length? It is transporting variable length packets which are known as datagram. Very, very important point. IP transport variable length packets called datagram. Okay, IP transport variable length packets called datagram. Okay, and next important point, each of the datagram which is transmitted, okay, they are independent, and they are transported separately, and they might follow different routes. Okay, it is not like that they will follow the same route and so on. That's why I'm saying it is connectionless and it is unreliable and so on. Okay, so each datagram is transported separately. Each datagram is transported separately, okay, and can follow different path. It is not like that it will follow the same path. Different path means like A is sending packet to B, there are multiple routers in between, so one packet will go like this, another packet will go like this. If you have any other router, another packet can go like this. If you have any other router, some packet can go like this. Anyway, okay. So whatever way they want, they can take. It is not like that they will follow the fixed path. Okay, yes. And what is the responsibility? Responsibility of IP, host to host delivery of datagrams. Okay, host to host delivery of datagram is responsibility of IP. Okay, so these are very important points, that's why I have written. Okay, take the snapshot, I will jump to the next slide.
Answer.
Okay, so now if you try to remember, I have told you in entire computer networks we will study 4 headers. First was Ethernet header, I have told you. Okay, Ethernet header. Second was I have told you IP header we will study. Then TCP header and then UDP header. 4 header we have to study. So now we are going to study IP header. It is very important. Many questions have been asked from this topic, and they will directly ask this field is of which how many bytes, this field is of how many bits, okay, what is the use of this field, and so on. So there are multiple fields, let me tell you that. So I will try to make IP datagram here itself. Okay. So very first field is actually it is not straight line. Yes. So the very first field in IP header is version. Okay, version. VER. Version is the first field. Next field is HLEN, that is header length. Next field is a service type. Next field is total length. Okay, so version is of 4 bit. I will write in bit terms of bits. Header length is 4 bits, service type is 8 bits, and total length field is of 16 bits. You have to by heart it. Okay, it is very important. So try to make it 2 or 3 times, you will get it. Okay, G. So next field I am going to write it. Next is identification field. Identification. Identification field. Identification field is of 16 bits. 16 bits. Next is flags, 3-bit field. Next is fragmentation offset. Fragmentation offset. It is of 13-bit. Next, TTL, time to live field. This is of 13 bits. Then protocol field. It is of 8 bits. then we have header checksum. It is of 13 bits, sorry 16 bits, 16. Yes, actually TTL is of 8 bits. Yeah, there is calculation mistake. 8. Time to live is of 8 bits. Protocol 8 bit, header checksum is 16. Next is SIP. Next is DIP. SIP. Source IP address, DIP. Destination IP address, and then we have options. Options plus padding 0 to 40 bytes. So total, if you see, this entire is 32 bits, na? So again 32 IP address is 32 bits. So total, if I say in terms of bytes, if we consider in terms of bytes, this is 4 byte, 4 byte, 4 byte, 4 byte, 4 byte, total 20 byte. Minimum header is of 20 bytes, and maximum, if options are 0, then obviously 20. If options are there, maximum 40 bytes, so it can go up to 60 bytes. So minimum header is of 20 byte and maximum it can go to 60 byte. IP header. Minimum 20, maximum 60. Okay. Yes. So you can take snapshot of this, and then I will done. Okay. Okay then. So let me start. I will tell you 1 or 2 fields. Okay. Time is up, so I will tell you just 1 or 2 fields. Let me jump to the next slide now. So first field is version. I have told you that we are in transition from IPv4 to IPv6. I have told you now in when I was starting IP addressing. So that means 100% IPv4, no. 100% IPv6, no. So obviously some packets will be from IPv4, some packets will be from IPv6. So this version field will tell about which IP version you are following. Okay, so if version 4 binary is 0100. If IPv6, then 0110. So simple. If IPv4, then it will be 4, and IPv6 it will be 6. IPv4, then it is this. IPv6, then version will be 0110. IPv6 header is completely different. Okay, but this first field will give introduction about which version we are going to follow. Okay. Yeah. Next is header length field. Header length. HLEN. Now it is very important. Header length field, I have told you it's just of 4 bits. 4 bits means you can go from 4 zeros to 4 ones. 4 0 means 0 and 4 ones means 15. So header length can go from 0 to 15. But what I have told you, header minimum is
4.
IP header minimum is 20 and maximum is 60. So how you will match it? In 4 bits you cannot store 20 or 60. So what we will do, we will multiply it by 4. Okay, so that means whatever will be the header length, you will multiply it by 4 to get the actual IP header length field value. Okay, so header length minimum should be 0101. That means 5. So that you get 5 into 4, that is 40. That is 20. Okay, so minimum value of HLEN should be 0101, and maximum it can be 4 1. So 4 1 means 15. So 15 into 4 you will do, that is 60. So our work is over. Are you getting it? So header length field is of 4 bits, 4 zeros to 4 ones, so 0 to 15. But header length minimum 20, maximum 60. So what we will say, minimum header length is 0101, that is 5. Maximum it can go till 4 ones. Okay, 4 1 means 15. That is 15 into 4, that is 60. So our work is over. 20 to 60. Okay, yeah. So now they can ask this question IP header arrive at router and header length field is 0100, what router will do? Router will simply reject the packet because minimum header length should be this. Okay.
Yes, sir.
Let me write the question. They will ask this type of question in gate. Okay. So or rather they will say like this: first 8 bits of IP header are 0100 0100. Packet accepted or rejected. So now you have to remember IP datagram. If you do not remember, IP header. If you do not know IP header, you won't be able to answer this question. So we say first 4 bits are version. That means version 4 we are taking. This is header length field. Header length field is 0100. That means header length is 4. So multiplied by 4, 16. Header length cannot be 16. It should be minimum 20. So it will be rejected. Like this you have to answer.
Minimum 15, no, sir?
Minimum minimum 20 na header length field, minimum 20, maximum 60. So for 20 you will put 5 na,
Yes, yes.
and here I have put 4.
Yes, sir.
Okay, so multiply by 4 we have to do na. So
Yes,
5
sir.
multiplied by 4, 20. So here 4 into 4, 16. Okay, 16 is not allowed, so it is rejected.
We do 4 only, sir. We can't make it match. Because we've got... Yeah, sir. Understood, sir. Understood, sir.
This was 4 na, so this was version, this was 4. We can put 101 here. If you put 101, I will say it is accepted. Because 101 means 5. 5 into 4, that is 20.
Yes, sir.
Any difficulty you are facing?
No, nice. Understood, sir.
Okay then. Okay, so that's it. So we will put till here itself, and we will start from here in the next class. Okay, so we have done version, header length, then service type, total length, and so on. One by one we will study all these fields. So you have to by heart this properly. Try to make it 2 to 3 times, you will get it. Otherwise you will keep on forgetting about it, and many questions have been asked in GATE. Directly they will ask identification field is of how many bits. Okay, directly they will ask total length, time to live field is of how many bits. Okay, header checksum is of how many bits. Like this they will ask. Okay, so very important, and they are free marks, free marks. Okay, one mark question, many times they have been asked. Okay, yeah, so that's it. So we will and this, for to answer this question we know this header properly, because first 4 bits are versions, next 4 bits are header lengths. That's why we have divided into 4 and we have answered this question. Okay, then we will wind up the class here itself. In the next class we will start from here. Okay, yeah, if you have any doubt you can ask me, otherwise we will stop the class here itself.
No doubt, sir. Thank you, sir. Good night, sir.
Okay then. Okay, good night, bye bye.